on the global climate development landscape. The world is undergoing a hidden environmental transformation, from the skyscrapers in bustling metropolises to the chimneys in inland industrial towns. 3. Invisible greenhouse gases, carbon dioxide, methane, and nitrous oxide, are shaping our climate along different trajectories. The sources of these gases are as unique as the fingerprints of cities. Carbon dioxide mainly originates from industrial energy systems. Methane permeates agricultural activities and fossil fuel leaks. Nitrous oxide is closely related to farmland fertilization. However, traditional research often focuses on carbon dioxide, neglecting the unique challenges posed by methane and nitrous oxide. Over 20 years, the global warming potential, GWP, of methane is 84 times that of carbon dioxide.
We used to think solving carbon dioxide issues means solving climate problems. But our research found that methane emissions in Chinese cities should contribute 20% to 30% to climate warming. More importantly, emission patterns vary widely among cities with different economic structures and population sizes.
The research team from Southwestern University of Finance and Economics integrated the Environmental Kuznets Curve, EKC, with 3 cutting-edge models: Gray prediction, XGBOOST, and LSTM neural network, and constructed the first 3-dimensional prediction framework covering carbon dioxide, methane, nitrous oxide.
Traditional model of any urban reality. For example, green models work well for small and medium cities with scan data, while LSTM can capture the non-linear emission trends of metropolis like Shanghai. Integrated models significantly reduce prediction errors.
The research reveals striking spatial differences. Industrial cities, for example, Datong, methane emissions account for as high as 35%, mainly for coal mining. Commercial cities, for example, Chengdu, the peak of carbon dioxide emissions is expected to occur between 2026 and 2028, which is 2 to 3 years earlier than that of industrial cities. Agricultural regions, for example, Harbin, nitrous oxide emissions show a continuous growth trend, and it is difficult to see a peak before 2030. Under such spatial differences, the prediction results regarding the peaking of greenhouse gases are as follows. The emissions of carbon dioxide are likely to reach a peak between 2026 and 2028. For some cities, the emissions of methane can reach a peak by 2030, yet there is no obvious peak for nitrous oxide.
The 2030 greenhouse gas emission forecast shows that emission patterns differ completely across cities with different economic types and population scales. Imagine making policies based on national average data. It's like forcing people to different sizes in the same clothes. This means we need city-specific emission reduction plans.
Based on the research team proposes a hierarchical strategy, highly commercialized. Cities can explore the replacement of traditional industrial technologies with new energy sources while continuously promoting technological upgrading to further tap into emission reduction potential. Cities with developed animal husbandry and agriculture should integrate ecological protection policies with greenhouse gas management and control.
The key is to break the size-fits-all mindset and adapt to local conditions. For instance, to control methane, we should mandate leak monitoring equipment in Shaanxi's coal mines while promoting intermittent irrigation in South Pandi fields. The same logic applies to controlling carbon dioxide and nitrous oxide.
The research not only provides micro-level support for China's double carbon goals, but also offers insights for developing countries. It underscores that only by understanding each city's emission characteristics can we construct a precise network to address climate change.